Hello, everyone. Welcome to today's Tech Excellence session. My name is Alina, and as you already may know, our vision is to raise the bar of technical excellence across the world. Who are we? Valentina. So, our well known Valentina, she's founder and organizer at Tech Excellence. Dania, Oliver, and Yuli, myself, we are co organizers and co hosts. So this year we prepared a lot of great speakers for you, so stay with us. And of course, you can follow us on different social media platforms such as Meetup, YouTube, LinkedIn, Twitter, GitHub, and Discord. Our sponsor is Optimum and our partner is QE Unit. So, to today's speaker. Today, we are very happy to introduce you Ahmed Misbah. Ahmed has been working with Agile methodologies and practices for almost 2 decades, starting with extreme programming and most recently DevOps. He wore many hats and Agile teams, including player, coach, Scrum Master, developer, and architect. He believes that being and doing Agile helps software development teams deliver great software solutions that make everyone awesome. He loves XP practices, and his favorite practice, you can guess, is of course TDD. So today, Ahmed will tell us about TDD anti-patterns. But before I hand over to him, I want to remind you, you can leave comments and questions anytime in the chat down below. In the end, we will have a 30 minutes time slot to discuss it. So Ahmed, I'm sure we will enjoy your presentation and good luck.
Thank you very much, Alina, and thanks to Tech Excellence for having me and your great team. And let's start. So today I'm going to be talking about TDD anti-patterns. So I'm going to start by introducing myself. I'm a chief software engineer and architect and an independent consultant and coach. I speak at multiple events, including DevOps Days Cairo, the African Middle Eastern Conference for Software Engineering, Orange Dev Desk Days, some local events where I come from, Delta Technopreneurs, Google Developer Group, and the Java Developer Conference. I speak about a lot of topics. Those include Agile and Lean, well, TDD being one of the many Agile practices I like to talk about. DevOps, cloud native apps and beyond, software architecture, Java, free and open source software, and artificial intelligence and machine learning. A little bit about my experience. Well, as Alina has said, I've been working for approximately 2 decades. Half of those are with my current employer, Orange Innovation Egypt. I've delivered 2 award-winning innovative solutions, worked at 2 startups, helped many others as a coach and consultant. Winner of the Dell Hack Trick 2022 UI UX track. Funny that a developer would win a UI UX track, but as Alina has said, I did wear many hats. And lastly, I have many professional certifications and academic degrees, including a master's degree in machine learning. Okay, so what are we going to talk about today? So I'm going to introduce what TDD is in just one single slide, because we mainly want to focus on the anti-patterns. Then we're going to be talking about 7 anti-patterns, okay? And we're going to conclude with a list of references I've used to prepare today's slides. There is a little bit of a backstory to this session, but I'm probably going to be telling you that at the end of the session. I'm not going to be wasting your time, so let's just get straight to it. So what is TDD? I think the best definition to what TDD is that which Martin Fowler has described. So it's a technique for building software that is guided by writing tests. So it is not a test strategy. It is a software development and design technique. It was developed by Kent Beck in the late 1990s as part of his famous extreme programming. And basically, you practice TDD by following 3 simple steps, consecutively, of course, and iteratively. You write a test for the next bit of functionality you want to add. You write the functional code until the test passes. And then you refactor both new and old code and make it well structured. And this is also known as the red-green refactor mantra. And we're going to be talking about that when we get to the anti-patterns. So this is basically what TDD is. Write a failing test, write just enough code to make the test pass, and then start refactoring. Start the actual design and writing the production grade code that you want. Push that to source control, and then move on to the next bit of functionality that you want to develop. Now let's talk about the anti-patterns. The first anti-pattern we will talk about is having no test list when you're practicing TDD. Now, what is a test list? If you want to know what a test list is, it's actually a TDD practice that was described by Kent Beck, or introduced by Kent Beck in his famous book, Test-Driven Development by Example, Chapter 25, Test-Driven Development Patterns. It's simply just a list of what you are planning to test for this piece of functionality or this user story you're planning to write code for. So it's basically what we are going to test. Moving on. So usually when we think about TDD, we only think about red-green refactor. And we simply think it's all about writing a failing test. And it's not actually just red-green refactor. Who invented red-green refactor? It was James Shore in 2005, long time ago. And it wasn't only red-green refactor. There was actually a step that preceded the red phase, and that was the think phase. Now, what are we supposed to do in the think phase? As James Shore has said, we're supposed to figure out what test will best move your code towards completion. And this is the phase or the step that should be taking most of your time, okay? And it's usually the hardest step for beginners. So that's why I said it's not just red-green refactor. Tests don't just come up out of nowhere. We need to think about what we are going to test. And that is where the test list comes in. And as you've seen, the inventor of the red-green refactor actually didn't say it was just red-green refactor. There was actually a think phase before that. And in the Coding Dojo Handbook, Section 3, the author describes how to do TDD using this figure over here. So again, it's not just red-green refactor. There is this phase before the red called overview. Now, what do we do in this overview phase? We analyze the problem, we write a test list, and we obviously write or author the guiding tests. And then we start moving to the red-green refactor phases. I actually get surprised when I see developers practicing TDD and they don't spend a lot of time thinking about what test cases they're going to be writing when doing TDD. It's usually not done in a systematic way, and you get really bad tests when you don't spend a lot of time in that think phase or that overview phase. Now, the screenshot on the right is from a YouTube video by Kent Beck. It's called the First 10 Minutes of TDD Intro Episode. That was actually part of a course that no longer exists, that was made by Kent Beck. But what I like about this video is that Kent Beck shows us how he does TDD. Okay, so that's the guy that rediscovered the practice doing TDD live. And what I liked about these videos is that Kent Beck practices what he teaches. And he starts off with this very simple to-do list with a list of things that he plans to test. And that is actually the test list. So the test list doesn't have to be something that is too detailed, okay? Like what you see when you're writing test cases, okay? Just bullet points with what you're planning to do. Prioritized, okay, by importance, and then you start writing tests for this test list. Now, how do we write a test list? I'm suggesting a couple of ways in this slide. So one way of writing test cases, and usually developers are not really good with writing test cases. They're good with writing tests, but not test cases, or at least from my experience. So one way to write a test list is to do the three amigos. Now, the three amigos is more popular when you're doing BDD. Actually, I think it's a practice that you should be doing all the time. Testers, business people, and developers should be collaborating all the time. And so when you're doing three amigos, when you're writing user stories, when you're writing acceptance criteria, when you're writing executable specs, or even when you're writing test cases, this can help you formulate good test cases for your test list. So that's one way. The other way is by doing pair programming or mobbing with testers, business people, or other developers. Probably more senior developers or developers that have more experience with the domain, with the business, with the code, with the project, with the product than you. So pairing and mobbing can also help you write a test list because you're no longer doing that alone. You're actually distributing that cognitive load over a couple of other people. Some people use test design techniques, the black box techniques in particular. These are also good to systematically formulate or write down or come up with test cases. And last but not least, you can use AI tools. Now, you can use something like ChatGPT. It's going to invent some tests for a specific piece of functionality, but we have to take care that it will not always be that accurate. Or you can use AI tools to augment your test list. So you've written a couple of tests, you've written production code to satisfy these tests, and then you want to augment your test list. You want to write down more test cases without having to think about these test cases. So there are AI tools like JTest, Machineit, Cover. These actually can read your production code and come up with more test cases. Now, this may sound like a test last approach, but I advise that you do so after at least writing down an initial test list, doing your normal red-green refactor cycle, and then using AI tools to augment your test list. So it will kind of improve your test list, probably come up with test cases that you didn't think about. So these are a couple of suggestions to how to write down a test list. And if you don't write a test list, I doubt you're going to be having good quality tests, because if you didn't give yourself enough time to think about what you're going to test, how on earth are you going to tell that you've written the right tests? So that's the first anti-patterns. And I do recommend reading this book, Effective Software Testing, A Developer's Guide. Now, this is a new book, and I would recommend that, if I can see correctly, chapter 2. Yeah, specification-based testing. It has this really good approach for developers, testers, whoever, that is an approach that is systematic and can help you come up with a good test list. Of course, the book calls the test list test cases, but who cares about the terminology, okay? We want a list of things that we are going to test. Okay, let's move to the second anti-pattern, no refactoring. Now, Martin Fowler talks about this and says that when you're doing red-green refactor, one of the ways you can really screw up your TDD experience is by neglecting the third or fourth phase, okay, depending on which red-green mantra are you following, the original one with the think phase or just the red-green refactor one. So if you want to ruin your TDD experience, don't do the refactor part, okay? Now, of course, it's better than not doing TDD at all. At least you have these little code fragments with tests, but you will not have good quality code written, okay? And you will probably be doing upfront design, which is something that we shouldn't be doing as Agile practitioners, especially ones that are doing XP. Now, what is the refactor phase anyway? Test-driven development e-learning album by Industrial Logic is actually one of the best places that explains what the refactoring phase is. Okay, so what they say about the refactor phase is that it is when you do pure design, and they also say that in TDD, design is actually something you do at the end, not at the beginning. So when we think about the traditional waterfall mindset, the way software development goes is that first you do upfront design, then you code, then you test what you have coded, and then you do refactoring if you think refactoring is necessary. Well, we always have a problem as developers, is that we always think our code is really good, okay? As long as we still remember what the code does, but then give it a couple of days, you've forgotten what it does, you've even forgotten that you've written that code, and you say, this is absolute crap. This is the traditional waterfall mindset. But when you're doing TDD, it's actually inverted. So the design is inverted and distributed. Inverted because it comes at the end, and distributed because it is evolutionary, it is iterative, it is incremental. You don't just do it at the beginning, you do it step by step. And we can see it in the diagram below. We write tests first, then we do the implementation, then we do the design and the refactoring. So remember that if you're doing upfront design, this is not right, especially when you are, a TDD extremist or a extreme programming extremist. You don't do any upfront design. Of course, I know that other people are against that. You have to do some upfront design. This is what the London side of software development always like to say, Martin Fowler, Simon Brown, etc. But anyway, just remember that we don't do the waterfall mindset anymore. So it is test, code, design, and refactor. Okay, so what do we usually do in the refactor phase? Now, okay, we understand that it's about design. We understand that we shouldn't be skipping it. We must be doing it. Now, what do we do exactly? Now, I got this list of one of the slides that were in this interesting video by Ian Cooper, TDD, Where Did It All Go Wrong? So the slides say that what you do in the refactor phase basically is remove duplication. This is what Kent Beck has said. It's when you sanitize the code smells. This is what Martin Fowler has said. And this is where you apply patterns. This is what Joshua Krivyaski has said. So this is what you usually do in refactoring. You remove duplication. This is where you apply the dry principle. You sanitize the code smells. So you need to have a nose to actually discover the smells, and you will need to read Fowler's refactoring book for that. And then you need to know what patterns you need to apply to clean these smells, or patterns to apply generally to have low coupling, high cohesion, etc. And this is what Joshua Krivyaski has said, probably in his Refactoring to Patterns book. So if you don't know what we do in the refactoring phase, here's an interesting list. And if you do these three things, in addition to a couple of other things, then you are doing design, and you will probably have code that is well designed, as opposed to not doing refactoring at all. Let's move to the third anti-pattern, no pair or mob programming. Now, if you decide to do TDD in solo mode, you get these three problems. You get a very steep learning curve because of all the technologies you have to learn, the recommended practices, etc. You have very little knowledge sharing because when everybody is working alone in a silo, we don't share knowledge regarding technology, recommended practices, business, test list, etc. We don't do that. Everyone is just working alone, and everything is really working with handoffs. Okay, so you finish a little bit of functionality, you move to the next. Somebody has to fix a bug in some code that you have written, but then they have to spend a little bit of time trying to discover what the hell this code is doing. And that's the problem with practicing anything in solo mode, not just in TDD. And lastly, you have less collective ownership of the production code and tests, because tests are written in code. So what applies to production code also applies to test. There is a cognitive overload that happens or that comes with that. So when you're doing TDD in solo mode, you have a very steep learning curve with TDD, okay? Because you're learning TDD basically alone. Whatever you learn, you don't share, so there's less knowledge sharing. And whatever you do is just owned by you and no one else, because no one else has took part doing whatever that you have done. And so you have less collective ownership. Now, when you're practicing TDD with doing pairing and mobbing, you get the opposite of all of what we've said previously. You get a less steep learning curve, you get better knowledge sharing, and you get collective ownership. And if you remember in the first anti-pattern, we've said that one of the ways that can help developers write a good test list is by pairing with other team members. And so, yeah, so without doing this pairing or mobbing, I consider this an anti-pattern, okay? Because you are going to do everything solo. There's going to be a lot of cognitive overload, and you're better off doing it with somebody sitting next to you or with a couple of people sitting with you in a room and guiding you to what to do, okay? It's a great experience, and you get all of these benefits from that experience. Okay, let's move to the fourth anti-pattern, no particular school. So when we're writing code or when we're writing a piece of software, we have to follow certain macro level architectures. So this is going to be traditional layered architecture, hexagonal architecture, or one of its variations or evolutions, onion architecture by Jeffrey Palermo, or clean architecture by Robert C. Martin. Okay, that's great. So yeah, we know now that we will follow one of these macro level architectures in our code. But with all of these different layers, where are we going to start when we are doing TDD? Are we going to start from the business logic layer, or from the presentation layer, or from the data access layer? Where are we going to start? Asking this question means that you are not familiar with the schools of TDD. And this can actually be a problem. You need to be aware of the two famous schools of TDD, the classicist school and the Marxist school. When you are aware of these schools, you know, first of all, where you're going to start. So if you're doing the classicist school, you know that you're going to be starting with whatever layer that is going to be dealing with behavior, whatever layer that is going to be concerned with business, and then any other pieces or components that this layer is dependent on are going to be handled using test doubles. And then we're going to be moving upwards or outwards with our tests. So this is the classicist school, sometimes, or some people call it the Chicago school or the Detroit school of TDD. Well, the Marxist school, or what is also known as the London school, they do things the other way around. They actually start from the outside, moving towards the inside of your architecture. Now, some people say that this way of testing actually tests structures or tests the mocks rather than the behavior. And it relies really heavily on using mocks as one of the many types of test doubles. Now, the point here is not to compare schools and not to say that one school is better than the other, okay? What we're trying to say here is that before deciding to practice TDD, you need to learn about the schools, understand what each school does, where do you start in each school, and in what direction do you move later on, and how much does this school rely on mocks and other types of test doubles, okay? And there are many places you can learn about schools of TDD. Now, because the classicist school is the most popular school, you'll find most literature discussing that. Very few material discusses the London school. The one I know of are the videos by Robert Martin and Sandro. They're called London versus Chicago. So at least this is one of the good resources I know that compares both schools and shows you hands-on exercises on both schools. So learn about the schools. They will help you know what to test, when to test it, and how to move on with your tests, because it's not just enough to test one component, okay? Obviously, you have to test that component with other components, etc. So this is the benefit of learning the schools. And if you don't learn the schools, you may find yourself perhaps just following the London school. Your tests are going to be less, they're going to be slower, you're going to be testing structure rather than behavior, and you're then going to be complaining that TDD is not good after all. It's not working for me. But then when you know that there are other schools, you may try these other schools and hey, TDD is not that bad at all. It's just that I was practicing a school that is not really working out for me. I need to work with a different type of school. So if you're not following a school, it's definitely an anti-pattern. And when you're following a particular school and then you learn about the other schools, this actually improves your TDD experience. Let's talk about the fifth anti-pattern, no integration. So again, when we're practicing TDD, it's red-green refactor. We've said earlier that there is the think phase before red. So it's think, red, green, refactor. But is it only just that? No. There is actually a phase after the refactor phase, and let's talk about that. So in 2011, Mike Hill, or G-Pow Hill, invented the microtesting. And it's not really that different from TDD. It just promotes the idea of making your tests really small and testing really small bits of code rather than having big unit tests and testing big pieces of code. Now, I know that this is currently a questionable topic. I've seen a video with techexcellence that was talking about having bigger unit tests and that they were actually better. So we've got both opinions. But let's just say for now that microtesting is all about writing these very little tests and writing very little bits of code to satisfy these tests. Now, Mike Hill has introduced the 4-beat cycle. This is an evolution to the red-green refactor mantra, and he added an extra phase after the refactor phase, and that is the integrate phase. Now, what do we do in the integrate phase? We commit our changes to source control, or what he describes as the source vault, okay? And then you start another iteration of the 4-beat cycle. So the good thing about following the 4-beat cycle is that it encourages developers to continuously commit their code to source control. When you commit your code to source control, you get many benefits. And we can simply describe those benefits as doing continuous integration. Now, the 4-beat cycle encourages you to commit to source control more often, so you have more frequent merges, more frequent pulls. You run your CI server more frequently. This may also promote the idea of continuous delivery, and it acts as an enabler for continuous testing. So if you're not really concerned about the integrate phase when you're doing TDD, you're just concerned about writing tests, satisfying the tests with production code and doing refactoring, and not really caring about committing the code frequently, you will miss all of the benefits of practices like continuous integration and continuous delivery, which are agile practices and extreme programming practices, and they give you lots and lots of benefits. So being in the 21st century, we need to say that integrating often is no longer an option, okay? If you're not integrating often, we should consider this as an anti-pattern, especially when doing TDD. So that's the 5th anti-pattern, no integration. Let's move to the 6th anti-pattern, no mutation testing. Okay, so I read this interesting tweet by Alex on Twitter, and he said that 2 things surprised him a lot recently. Experienced TDDers who don't see any value in mutation testing, and the number of TDDers that don't see any value in test commit revert. Now, we're not going to be talking about test commit revert, so let's just focus on mutation testing. So what is mutation testing? So when we think about measuring the quality of our tests, what usually comes in mind is code coverage. And that's basically how many lines of code does your tests cover. And I think many of you have already read that this metric is not always accurate. It's not always an accurate measure to measure the quality of your tests. And it's not enough. So we need something more. And this something more is mutation testing. So what is mutation testing? What happens in mutation testing is that something messes up with your production code, and then when you mess up with the production code, you have mutants. This production code is now called mutants. And then you start executing your test suite against those mutants. And if the tests fail, then the mutants have been killed. And if the tests pass, then you've got mutants that have survived. And mutants that have survived are actually something that raise questions. Well, they're called mutants, so they're actually bad things. So some people call mutation testing as the gold standard against which all other types of coverage are measured. And some people say that this is one of the best metrics you can use to measure the quality of your tests. Now, I always like to tell the story. I was doing a mutation testing session without using tools. We were doing it manually. I read a piece of code, and I told the developer to change something in the behavior of the code. And surprisingly, the test passed. So I told them, this is a really bad test, and it needs to be rewritten so that if we change the behavior of the code, the test would capture that. Okay. So as I've said, it works, and it is a really good measure to the quality of your test suite. And it should be used next to or alongside with code coverage. And you've got many tools that does that for you right now. So really, there should be no excuse why developers wouldn't be doing that when they're doing TDD. So maybe people started talking about mutation testing a few years ago, but I consider it now as an anti-pattern. Okay, if you're not doing mutation testing, you don't really have that gold standard to measure the quality of your test suite, and this is bad. I think it's an anti-pattern, and I think that all TDDers, not just experienced ones, should have mutation testing as a practice that they do alongside with TDD. Okay, the seventh and last TDD anti-pattern is practice plus technology before theory. We've all been there, we've all done that, okay? So you watch a course on some online platform, you watch a couple of YouTube videos, you read a couple of articles, you study the technologies, and then you jump into practicing TDD. That is actually an anti-pattern. Now, let's first talk about this interesting equation that was, I first heard it by Ahmed Galal. I was attending a mobile UX session in 2012, and he wrote this interesting equation in one of his slides. Now, I'm not sure if he's the inventor of this equation or not, but anyway. So he said that experience equals knowledge plus practice. I like that very much. So Usually when we talk about experience, we use this term interchangeably with practice. So when we say this is an experienced guy, we mean that he has many years of hands-on practice on his shoulder. But that is not very accurate. Experience is not just how much you've practiced, it's also how much you have studied, how much you've learned, how much you've read, how much you've listened to. Okay, this is what experience is. So it's both how much knowledge that you've gained and how much of that knowledge have you applied or practiced. And this quote here by Edwards Deming in his famous book, The New Economics of Industry, Government, and Education, supports this point of view. Note that Deming here uses the word experience to denote practice, okay? So he's saying that practice by itself teaches nothing. So when your experience by itself teaches nothing, and by experience here he means practice. Without theory, experience has no meaning. Without theory, one has no questions to ask. Hence, without theory, there is no learning. Now, I like that very much, okay? It basically says it's not just enough for you to read a couple of articles, watch a course, and then start practicing right away. Okay, you're definitely going to be doing a lot of things wrong. Now, in order to handle this anti-pattern, what I recommend is that beginners or even experienced people give TDD a lot of time of reading before practicing. And I recommend that people start with reading Kent Beck's book, Effective Software Testing, which is the book I've mentioned in the first anti-pattern. Read about the 3 laws of TDD and understand what they're all about. Of course, these were explained and invented by Robert Martin in his famous book, Clean Code. Learn about the first properties of TDD in Robert Martin's book. Now, Robert Martin is not the inventor of the first properties of unit test, but he does explain them really well in his book. Test Desiderata. This is an excellent list that was written by Kent Beck. These are characteristics that your test should abide to. And he has this really great playlist on YouTube explaining each of these characteristics. And of course, there is the TDD manifesto. So these are things that I recommend people read before learning technologies and before practicing, okay? I consider these as the gold mine of knowledge of TDD. Now, if you have not read those and you've jumped straight into Jasmine, JUnit, NGUnit, Cucumber, etc., and you've practiced that straight away in a production project, you're definitely going to be getting lots of things wrong, okay? So build knowledge, start with theory, and once you have solid theory and solid knowledge, start complementing that with practice, okay? Otherwise, you'll be simply doing the 7th anti-pattern. So this is it. These are the 7 anti-patterns of TDD. Having no test list, doing no refactoring, just red, green, red, green. Not doing pair or mobprogramming, not following a particular school, or at least not knowing about the schools, doing no integration, or doing integration not very frequently, having no mutation tests or mutation testing as a practice, and last but not least, practice plus technology before theory. So this is where you just watch a 101 course that will mostly cover the technology, not the fundamentals, and then you start practicing in a real project. These are the 7 anti-patterns that can ruin your TDD experience and can eventually lead to people saying, TDD is not working for me and it doesn't work at all. Let's just stop doing it and everything else goes wrong afterwards. So these are the anti-patterns. And this is not a list that I've copied off the internet. There is actually a backstory behind this list. Every year, my employer has this event called the Dev Test Days. This is where geeks do sessions on technologies and practices. And every year, my team likes to do presentations about something that we have hands-on experience with. So I've been practicing TDD for about 16 years now. And I thought, why not just write all of the bad things that I have done in these 16 years, all of the bad things and the anti-patterns. So the list you see in front of you here right now, as I've said, this is not something that I've copied off a book or off the internet. These are actually stuff that my team and I have done wrong, and when fixed, they actually improved our TDD experience. So this is a list that comes from hands-on experience, and yeah, the guy who's speaking to you right now, I've done all of the 7 anti-patterns. Okay, I've seen how they ruin the experience, and I've seen how the experience improves when these anti-patterns are fixed or at least handled. So there you have it. These are a list of books that I've used to prepare some of the slides. And these are recommended readings, classics that I recommend that you read regarding TDD and refactoring. And I do recommend this book for developers, especially for the first anti-pattern, the no test list. It teaches you how to write a test list in a systematic way. I like it very much. It's really good. So this is a recommended reading. So thank you very much. And I think we have still some time left. So if anybody wants to ask any questions, feel free to send me your questions. Or, of course, open something up for discussion.
Thank you, Ahmed, very much. It was an amazing presentation. A lot of discussions are going on in the chat right now and quite some questions. So we picked quite some. Let's look at them. So one question from Peter. So a test list translates to know your functional requirements. So what's your opinion about this one?
Okay, so if you read the book I have recommended, one of the phases that you need to execute in order to write down a good test list is actually to understand really well your functional requirements. Okay, and as I've said, the best way to know your functional requirements is to collaborate. And you need to collaborate with your PO if you're doing Scrum, or with your on-site customer if you're doing XP, or whoever that is representing business or the end user. You have to collaborate with those to understand what they need. And you need to collaborate with testers, because testers have this great ability to turn anything into test cases. Okay, they're really good at doing that. So yeah, knowing your functional requirements is one of the way to have a test list, or functional requirements will eventually translate to a test list. Okay, but I can't really say that know your functional requirement is AKA have a test list. No, it's a way that you can formulate a test list, because there was this famous quote by someone, but I don't really remember who. He said that without requirements, you shouldn't be doing anything. You shouldn't be architecting, you shouldn't be designing, and you shouldn't be doing TDD. And without requirements, you're just writing bugs on your IDE. So yeah, everything starts with good requirements. And what better way to have good requirements than collaborating, three amigos or whatever.
I found this quite a good question, and I would also like to add something here. So even by definition, an automated test is an executable requirement or executable specification. So that's yet just an additional reason why we need to start off with requirements. And the word functional. So everything that we're doing through TDD is essentially functional testing. It is not performance testing. It is not reliability or any other quality characteristics, but purely functional. And we could look at this, the formulating of test list, as some sort of rough upfront design. So rather than just jumping straight incrementally into the very first test case that comes to our mind, we're doing very rough upfront design. So we have requirements translated to tests, and then we could prioritize that list as we go on.
I think adding to what Valentina has said, one of the good things about having a prioritized test list is that you may discover at some phase that you will no longer need the rest of the tests, or that you can remove some of the tests even after they've been written. Okay, so like with user stories, test list is really very important, because you don't want to, because code is evil. Okay, and you write tests using code, and you don't want to be having lots of test code to maintain and run. So having a test list actually allows you to kind of filter out what you really need from what you might have just written down in a couple of minutes on a piece of paper on a to-do list, and then you find out later on when you build up this experience and maturity that I don't need this anymore.
Great discussion. There actually was another question about the list. Let me show this one. So I assume lists of tests can grow since more and more functionality and features are required.
Yeah, you're absolutely right.
What's your experience about growing?
Okay, so let's talk about the growth of the test list from two perspectives. Okay, first perspective is that, as Valentina has said, you start up with an upfront list. Okay, and this list is going to eventually evolve. Okay, and we've said that you can evolve the list either by collaboration or by using some AI tool that may do that. At most at human level. Okay, so this is one way, and in the book I've recommended, they call this augmenting the test list. Okay, so you already have a test list and you want to be adding more tests to that or improving upon this test list. So this is one way your test list can grow for a specific piece of functionality. Now there is this other big global perspective, and that is, we write software for it to grow and evolve. Okay, so this is actually something that software is all about. I remember Robert Martin in one of his videos saying that the word software, soft means flexible and ware means product. So flexible means flexible to change, and growing is part of that. So when you have a piece of software that is flexible to change, it means that it is flexible to growth as well. So your test list growing is not an assumption. It is a fact. It will happen either by augmenting the test list or by the software growing and expanding in terms of functional requirements and other stuff.
Yeah, I would like to add a bit here. I really like the way that you brought this topic up. This test list is a really underrated practice among the TDD practitioners. And what I also personally do, and I think also Ken Beck does it in his book, that he uses this list not only for tests, but also for a to-do list. So let's say you have 4 or 5 different things you want to refactor. You don't keep it in your mind. You just write it down in this list so you can use it in the future. So personally, also that's what I do. That I use this as a to-do list instead of a test list. So I write down all the tests I want to write, and also a lot of refactoring and other ideas. So, but yeah, great point. Thanks.
Yeah, and I just want to add to what both Daniel and Ahmed said about the test list and combining it all together. And again, coming back to Kent Beck, so essentially we have only 2 types of changes: behavioral changes and structural changes, which is refactoring. So behavioral changes, this is where the trigger is we want to write a new test or change a test. So that's the part where it's like the list is comprised of future planned tests. Whereas the part for intended structural changes, like the refactorings, that's the part which is essentially like a to-do list for refactorings. And it's really important that these are split together, that we are they're essentially split, that where are we working on, behavioral change or structural change. So the question is, will you have one list where maybe you mark which ones of them are behavioral, which are structural changes, or even having 2 lists or something. But this is excellent. That is actually the full list of our activities. And in fact, this is pretty much, this to-do list then comprises what we'll be doing for 99% of the day. Okay, aside from the macro activities, but that's pretty much it.
Great discussion. Let's move on to the next question. So this one you partially already answered in your presentation, but still, how to approach learning TDD as someone who is new to it? Maybe you guys in the round have some additions.
I actually have what I call the adoption plan, but of course this is in the in some other workshop that I do. So basically, if you want to start your TDD journey, the first thing we're going to do is first think about the 7th anti-pattern. So we want to start with a really good foundation, and this is what I call in the adoption plan understanding the basics. Okay, and of course I recommend TDD by example, effective software testing, the 3 laws, the first properties, the test desiderata, and the TDD manifesto. Okay, so this is the first thing you need to start with, and that is understanding the basics. Now, once you understand the basics really, really well, the second phase, I call it beyond the basics. Okay, so this is where you can start learning some sort of technology or library so that you would practice TDD with. And of course, you're going to be picking up a library that is popular with your favorite programming language or stack. And it's not just enough to learn the library. Every library has patterns. Okay, so you need to learn these patterns as well. How to put your system in a state that it should be in, before executing the tests, then how to execute the tests, then how to clean up whatever that your tests have mutated. So you need to also learn some patterns that are associated with the kind of technology that you're going to use. Of course, in this phase, the beyond the basics phase, I added my TDD anti-pattern session. So obviously you need to know the anti-patterns as well. Then start practicing on a greenfield project kata. Now, there is the Coding Dojo handbook. There are some really good katas in this book. And you've got the book's website, codingdojo.org/kata. So start practicing what you've learned in terms of knowledge and technologies on greenfield project katas. Once we are done with that, start practicing on brownfield project katas, okay? Because when you're doing TDD, it's not always sunshine and roses. You're not going to always start with a greenfield project. Sometimes you will have to start your TDD in a project that is already running. So how are you going to approach that? So you need to be doing some brownfield coding katas. And I think there is no excuse whatsoever why a development team can do a kata 1 hour a week during working hours. I see no excuse whatsoever not to do so. Have this practice in your development teams. Let's do 1 hour of coding kata on TDD or whatever practice on greenfield katas and brownfield katas. Then I recommend you learn about TCR and microtesting, because these are practices that are specifically focused on brownfield projects and legacy code. So this is going to help a lot. Then spike TDD in your real project and then start implementing TDD in a real project. So this is kind of my idea of an adoption plan. Of course, people can disagree with me on some of the things I've mentioned, but so it's basically read some books, learn a piece of technology, start practicing on katas, and then start your adoption in a real project. Don't start with a real project, because if you ruin things in a real project, you will have everyone in the management team tell you, this is really bad. Why did you do this? Stop doing this. Okay, so you want to do it the first time, right the first time. Okay, at least with management, and you can do that an hour every week. Okay, this has worked for me, has worked with great people I'm working with, and I think it will work for some people. I think so. If you get fired, it's not my fault.
Yeah, great suggestion. I could imagine if you are new with TDD and you're starting with katas and on greenfield katas, and you know, oh, this is working, but you have to do this shift to your, let's say, legacy project. It might be frustrated at the beginning. Do you guys have experiences with this one?
Yeah, I love this adoption plan. And what I would add here is that it's a really good practice also to find a study buddy who you learn with. Let's say, because it can be that not all your colleagues wants to learn TDD, right? Maybe you are alone, huh? Or maybe someone is working isolation, unfortunately. And you know, you need to. It's if you find a study buddy that really gives you more motivation, you can share the knowledge, you can explore together, and of course, mentor can help a lot at the beginning, and or a coach if you needs a coach that also can help a lot to speed up the development process.
I fully agree.
Yeah, exactly. And I guess regarding those two pathways, it could be summarized. You know, what is the context of someone who is trying to learn TDD? So first of all, are they working in a company where no one else is practicing TDD and they are learning alone and have no access to coach, no access to trainer? I see that as one learning path, whereas the other learning path is organizations where either there's already someone internally who has practice in TDD and will act as an internal coach or getting an external coach. And I see those two pathways as being critical, because if someone is learning it by themselves and has not seen it, is not seeing it anywhere, then I find everything that Ahmed said to be really spot on. You know, starting with katas, not in production code, doing it small. I would also recommend, you know, feel free to make your own GitHub project. Firstly katas, but then do a GitHub project for, let's say, an e-commerce system or something which is sort of imitating a real project, experience the mistakes there. Then only when you feel confident to introduce it in production. I fully agree with the statement, you will have only one chance with management, and if you mess it up, not only do you mess it up for yourself and your own reputation, but even worse, then the rest of the company might say, oh, look, this project, TDD was tried there, it failed, hence we will never do TDD ever again. And then management essentially bans the possibility for anyone else to do a TDD. So that's why in that case, if you're doing it alone, and I know this is a high pressure statement, it has to go well the first time. And to get to this point, it might require a lot of your own personal time, even beyond the 1 hour kata. You yourself might need to practice quite a lot, and your company may or may not support this possibility. But in the other case, where you have an internal or external coach, where you have someone guiding you, they can immediately proceed to pair programming and mob programming with you, and they can already start transferring the why and the how, and just shortcutting the process a lot.
I agree. PR and mob programming is a key for a lot of problems. Let's stay at this topic for a while. I will show you another one. What is the best way to apply TDD for large running projects? We partially touched this topic, but maybe we could elaborate more on this one.
Yeah, I think it's the adoption plan, but then so if we're talking, it's going to be really challenging when it's you've already said it, sorry, a large running project. So we're talking about a brownfield project, okay? And if we're going to take Michelle Feather's definition of what legacy code is, so legacy code is code without tests. So it is legacy code, okay? If it's a running project with no tests, then it is legacy code. So I recommend TCR or micro testing, okay? Test, commit, revert. It's a new practice that was invented by Kent Beck. It may sound very, very radical, but it's excellent when you're dealing with legacy code. Why? Because when you're dealing with legacy code, you're either going to add new functionality, fix or tweak something, okay, or what was the third part? I don't know. Well, let's just say you're going to either add functionality or fix or tweak something, okay? So in TCR, what you do is that you write a piece of test, okay, for this new functionality or this piece of code that you're going to modify or fix, okay? Then you write very, very little production code. If the test passes, it is automatically committed to source control. If it doesn't pass, the code is automatically reverted back to when it was working. Because usually what happens with legacy code is that, okay, you write a piece of test, you start ruining the code, it doesn't work anymore, and you don't remember at which part the code was working and what messed it up. And so this is the good thing about TCR, is that if you mess up the code and the test is not running, you go back to the point where it was running and you start all over again. So what you get here is that this forces you to write very small pieces of tests against very little bits of modifications you want to do. So if you lose those in a revert, it's not a big loss. You can always repeat it again, and you have your test list to remind you of what you were doing. And if it works, roll as something that is stable and working. So I think TCR is an excellent practice if you're going to be approaching legacy code. Okay, I think it's better than traditional red-green refactor, and it does really work. And you're going to suffer at the beginning because you're not used to having the luxury of having the tests go red and hey, I can just continue on. It's okay. You're going to suffer a little bit from the revert part, but then once you gain the experience, you're actually going to find out that it's a good thing. So this is my recommendation for large running projects, simply TCR.
Thank you very much. Let's move to the next question, which is actually also very familiar to myself. So very interested about your opinions. A question from Steven. How do you use TDD effectively on a team but does not use TDD? I have tried, failed, and left that job.
Okay. This is a very difficult question. Now, I'm sorry you left the job. Yeah, I know that when you start seeing things failing, it really, hits you hard. But let me say this. I'm going to argue that if you follow the adoption plan I've just mentioned, definitely a lot of people are going to drop off and are going to resist so much that you're going to say, hey guys, well, if this is the way we're moving forward and you're absolutely not convinced, maybe switching to another team would be a better option. What I'm saying here is not that bad because I've read that in books. Okay, some books tell you if you're a Scrum Master and you've got team members who are resisting whatever you do, they're not convinced with this whole Agile thing, well, they can always transfer to some other team that is not doing Agile. It's not going to hurt anyone, and everybody is going to be happy. Okay, so Agile is all about collaboration and communication, and if the team is not aligned, how on earth are you going to have that? So when you're following the adoption plan, when you're having a study buddy, or you're doing mobprogramming, or if you're doing katas, you're going to, detect team members who are potential Agile team members from the ones who are completely resistant, the Jivaras against Agile. You're going to be detecting those, and well, you will have a very difficult decision to make, and they will have a very difficult decision to make as well. So it's not always easy. Our profession is all about people dealing with each other. Okay, it's a very human-centric industry. Okay, so if people are not able to work together and are not aligned, it's not going to work out. So the difficult decisions will then have to be made. So I hope this answers your question.
Yeah, Steven added a quote: if you can't change your company, then change your company.
Yeah, well, if you can't change the company, then yeah, simply leave the company. That's why I said there will be a difficult decision to make.
But so in your experience, what is like the percentage of, you would say, companies that are more likely to adopt TDD and those that aren't? So in your experience, because if you try to leave and then it's like you come from one to the other and it's the same again, and at some point you just run out of options, right?
Yeah. Well, let me tell you something. From experience, it's all about mindset, really. I've seen big companies who didn't micromanage people and they let people do their thing and things were working out really well. And I've seen startups who are like just 10 or 15 people and they were resisting TDD. So it's really all about the mindset. And when it comes to mindset, I think it's like tossing dice or tossing a coin. It's all about luck, really. I know this is not the answer you've expected, but when it's all about people, it's really all about luck. If you're dealing with people with the right mindset, you're a lucky guy. If you are dealing with people who are not aligned with your mindset, I don't want to say that one mindset is right and the other is wrong, but let's just say if we're not aligned, then it's bad luck. It's difficult to change mindsets. Some people are open to change. A lot of people are not, so it's a difficult thing.
Correct. So I would say the deeper question here is actually it's not about TDD, but it actually goes to the deeper mindset issues, because certain kind of mindsets will be receptive to extreme programming, TDD, mob programming. That's like one category, and then there's other mindsets which simply value a completely different way of working. So I've met, certain managers who really understand what's the value of adequate, test reliability and stuff like that, and who would be interested in test automation and TDD, and who value clean code. But there's other kinds of managers who actually prefer any spaghetti code and developers working overtime and delivery through whatever means, and they reward and recognize those kinds of people. So I guess it comes down to what is the mindset, because the mindset is something that you can't really change. So it's not about are they using or not using TDD, but is their mindset receptive or not. If it's receptive, you will have high chance of success, assuming you follow a reasonable adoption plan. But if the mindset is not aligned, then even in my experience, it will not work out. And it's like you then need to find someone where there is mindset alignment.
Yeah.
Volka just made a reading suggestion regarding the mindset. Software Craftsman, Professionalism, Pragmatism, Pride by Sandro Mancuso.
Yeah.
So
great book.
If you're interested, read this book. So we don't have so much time left. Let's move on. Elias asks, what is the black box technique?
Okay, so if you're into software testing, there are three test design techniques. You've got white box techniques, black box techniques, and exploratory techniques. So black box techniques is where you know nothing about structure, you know nothing about the code, you're only aware of functionality and behavior, and you start designing your test cases based on that. Now, these include equivalence partitioning and other test techniques. White box techniques is when you know structure and you know the code, and you start following one of the techniques, okay, that really test structure rather than behavior. Exploratory is when you don't follow any systematic approach. You rely on intuition and experience. Your experience with this application, with these types of the application, with the business, with the domain, with the development team, and you start testing with this experience in mind. So you don't really follow any systematic approach. So this is it. A black box technique is when you know the functionality, know the behavior, and you use one technique to test those. Okay, and The ones I still remember are equivalence partitioning and boundary value analysis. I think there are decision tables. There were other techniques, but I don't remember them all, to be honest. Okay, so these are basically the black box techniques. So I use boundary value analysis and equivalence partitioning when I want to come up with different tests with data and forms. Okay, so you want to test the age when it is less than blah blah blah, more than blah blah blah, stuff like that. You've got a decision table where you have all of the different permutations of data. You can use those to have a test for each permutation. So this is one technique that can allow you to come up with a test list, but you will eventually filter out this tests that come out from these techniques. I think there is one technique called permutation something. I don't remember that. You come up with lots and lots of tests, okay? And yeah, I think you will have to filter those. So I recommend that you read some book regarding testing, or the body of knowledge from ISTQB. This can help with or some software engineering book, the academic books. These will have those explained really well.
Thank you, Ahmed. So Cosmere asks, inside out or inside in? Which one do you usually use, and on which kind of projects or architectures?
Okay. I'm going to surprise you with something. I don't relate the approach with the architecture. Now, I know this is an unpopular opinion, okay? If I'm doing BDD, I do outside in. If I'm not doing BDD, I do inside out. This is my basic formula, okay? There's not a lot of engineering in that, but this is the way I like to do it. If I'm doing clean architecture, of course I do inside out, okay? So this is basically what I do. I think with the clean architecture, and I think Valentina has lots of sessions regarding that, you will definitely follow the classicist approach, okay? With any other project, or any other architecture, it's really up to you, okay? You see the school you find fit. But when we're doing BDD, we usually do the outside-in approach.
Yes, and I think it's good that we're having these discussions, and anyone, feel free to watch Uncle Bob's videos regarding the TDD schools, the Chicago versus London style. So Uncle Bob shows how he is applying a classicist TDD. He's doing it in an outside-in way because he's starting with the use cases and applying it to clean architecture. And that also happens to be the approach that I'm using, and which is also visible in my meetups. But essentially, it is orthogonal. So someone could, you could have clean architecture as your architecture. You could do outside in, classicist style, which is what Uncle Bob is doing, starting with use cases. But there's other people who may do it inside out, and they start off with the domain, not the use cases. And the other thing I also want to mention on the word outside in, I know that sometimes people might say outside in is synonymous with London school, but actually in classicist TDD, you can also do outside in if you are not starting with like the entities, but are, let's say, starting off from the use cases. So that's outside in classicist TDD style.
Great, thank you, Valentina, for this edition. So I guess the last question for today, there was one from Beta. But if you practice through TDD, all paths are tested, so would it not be really rare to see a mutant survive? What are your
Okay.
on this one?
This is good. Okay, now The last part of your question, so would it not be really rare to see a mutant survive? The only way you can answer this question is by doing mutation testing. So really, how do I say it? I think that's why you have measures in place. It's to make sure that you're practicing TDD the right way, or at least practicing TDD produces tests that lead to seeing less mutants. Okay. So I would say that this is more of a statement rather than a question. Yeah, you need mutation testing to make sure that all paths are tested, though I think this is more code coverage and other stuff, and to make sure that you're doing true TDD. So yeah, I'm not sure if I've answered your question, but I think it's more of a statement, and it's a correct statement. It actually, how do I say it? Approves of the sixth anti-pattern, and that is when you don't have mutation testing, you're not really sure if you're doing TDD right or not. And there are, of course, other measures. Your code quality, your improved lead time, the defect rate, though, yeah, some people might disagree with me on that. So you've got many other metrics, but at least this is one of the metrics that we use.
I would add here a small bit. I totally agree with that, practicing TDD leads to maximize the code coverage and also maximize mutation score. But based on my experience, sometimes we humans, right, human beings, we are making mistakes. We can be tired, we can miss a case. So sometimes we take a bigger step when we implement, when we make a test pass, right? So when we're doing that, we can personally use mutation testing tool as a quality check. So that can really help. But as you're just checking my work, you just, not quality assurance, but checking that whether it's sort of sanity check.
Exactly, it serves as a check for everyone, and there's a difference when someone is doing, test-driven versus test-last. So if someone is doing test-last development, typically they will get quite a low mutation score. So they could have code coverage 80%, but the mutation score might be 20%, 30%, or something very low, very far away from 100%. Whereas people who are doing TDD properly, the ones who are doing it properly, they will be essentially getting something like 100% or 99% due to possible, how should I say, missteps. People who are sort of doing TDD partially, but maybe not properly, they will get a lower mutation score. So there's a difference. If someone is doing test last, they use mutation testing as the only way to get to a reliable test suite. But with TDD, you use it just as a sanity check, just in case you made an accidental mistake in those rare times, such as the example that Daniel gave, where you took a step that was too big. You wrote more code than was needed to pass the test. So it serves as a sanity check there. And important point is put mutation testing on a separate pipeline. So it's not part of your regular build where you execute unit tests or something. Put mutation outside on separate pipeline due to the execution time.
So thank you very much for this great discussion and amazing questions. A special thanks to Ahmed for this amazing presentation.
Yeah. Thank you very much. The great team at TechExcellence, and hope to see you in another session.
Exactly. I found this to be an excellent session and really great topic, because you actually handled the anti-patterns, which is probably the most helpful thing, because that is what the kind of challenges that many teams are experiencing. So thanks again. It was really great.
Thank you very much,
Most
everyone.
welcome. Thank you.
Thank you.
Don't forget to follow us on social media and have conversations with us on Discord and learn how to deliver quality software faster. So see you another time. Bye-bye. Have a great evening.
Okay. Bye-bye.
Thank you. Bye.